All right, ladies and gentlemen, welcome to Unit 4 on our Accuplacer Prep course. This is going to be all about fractions. Okay, so we're just going to go through the basics of fractions, so adding, subtracting, multiplying, dividing, and probably the most annoying thing you have to do with fractions, which is finding common denominators. Now, the first thing we're going to go over very quickly is multiplying fractions, because it's actually the easiest thing to do. Because as long as you have two fractions and you're multiplying them, then you very simply multiply the tops, or what are called the numerators. So in this case, that's 3 times 7. And you're multiplying across the bottom, which are called the denominators. So this is 4 times 4. So 3 times 7 is 21. 4 times 4 is 16. That's it. That's very simple to get to our answer. Multiplying is very straightforward. Multiply the top, multiply the bottom. So on this second example, you'll see we want to be a little careful for something. You can go right through and do exactly what I just said. Multiply the top, so 3x times 5 is 15x. Multiply the bottoms, 2 times 6x, 2 times 6 is 12, so this is going to be 12x. But then you always want to be a good math student and simplify. So these x's will cancel. 15 is really 3 times 5. 12 is really 3 times 4. So even the 12, or the 3's are going to cancel. And we should be left with just 5/4. Okay, and that's kind of a lot of simplifying. So something that you could typically do right away, however, is simplify early. So this is 3x over 2 times 5 over 6x. So because I know that everything in the top is going to be staying in the top, and everything in the bottom is going to be staying in the bottom, you can actually simplify before you multiply. So I have an x in the denominator, an x in the numerator, those are going to cancel. And then I can reduce everything by a factor of 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. And so I can kind of reduce before I do any multiplication. And I get 1 times 5 is 5, 2 times 2 is 4. And I get to my answer of 5/4 that way. Okay, so let's simplify before we multiply on the bottom. Is there anything I can simplify? I think so. The 2 and the 4. So 2 divided by 2 is 1, 4 divided by 2 is 2. And then we just multiply across. 1 times 3 is 3. 7 times 2 is 14. X times x is x squared. Okay? Or if you want to write it more neatly, I suppose, this is 3 over 14 x squared. Okay? So multiplying, very straightforward. Just multiply the numerators, multiply the denominators, and it stays a fraction. Okay, so when people think about adding, subtracting, multiplying, and dividing, they typically think that multiplying and dividing are harder. But what's odd about fractions, and I think the reason why most people really just hate fractions, is that adding and subtracting is actually more difficult because you need to do some prep work, because you must have a common denominator, okay? So it's kind of like adding like terms. Like you don't want to be adding thirds to fourths. Like that's not like a very easy thing to do. You don't really know how to do that. So I want to look at things that are kind of the same. So looking at all fourths, for instance. So in this first example, 3/4 plus 7/4, those already have a common denominator. So that becomes quite easy. That is literally just 3 plus 7. And they're all measured in fourths. So I can add them like that. So 3/4 plus 7/4 is 10/4. Okay? And you will probably not see that answer in your multiple choice answer on the Accuplacer because it is not simplified. So 10 is really 5 times 2, and 4 is really 2 times 2. So this does reduce. You don't need to do this step, but it's nice to see it. And it all reduces to 5/2. Okay? So on our second example here, I cannot just add the 1 and the 5 like I did before because our denominators are not the same. Okay? So I have 1/2 plus 5/4. I want to say, well, what is a common denominator that they could both get to? And I think they could both get to 4 very easily. So I have to ask myself, what do I have to do to make this 2 a 4? And I have to multiply it by 2. Okay, so you want to ask that question to yourself always through multiplication. and not through addition or something like that. So I'm going to have to multiply this by the number 1, which is 2 over 2. Okay? And that's going to give me 2/4 plus 5/4. Okay? Because when we are finding because when we are multiplying fractions, you are just multiplying the numerators and you're multiplying the denominators. And so once I get to this step, now they do have the same denominator. So this is now just 2 plus 5 over 4, which is going to be 7/4. That does not reduce, so that is our answer. Okay? Now sometimes you're going to run into a problem down here where you have 6/5 minus 10/3. So these don't even seem to be anywhere close as far as common denominators. Where I actually have to multiply both of these by something. So 5 and 3, they don't have anything in common. So I'm going to multiply this first fraction, everything by 3, and get a common denominator of 15. Multiply the second fraction, multiply everything by 5. Get a common denominator of 15. And so I have 3 times 6 is 18 15ths. And this is minus 10 times 5 is 50 15ths, which is just going to be 18 minus 50 15ths, which is, if I am doing this correctly, 18 minus 50 is negative 32 15ths, which they do not have anything in common, so we are good to go from there. Alright, so we're going to keep going with the adding and subtracting, but now these have kind of like algebraic denominators. So I feel like in this first example, can I add them? No, they don't have the same denominator. So what do I have to do? Well, I have to get a plus 2 on that second denominator, right? Well, no, because you can only change things through multiplication for this. So I want to look at that x plus 2. That's its own thing. It is actually so different from x, it's not even funny. So you look at those two terms and you think, oh, well, there's an x plus 2 and an x. They're actually very similar. There's just a plus 2 that differentiates them. Well, that's not really true. They're actually very, very different numbers. So, for example, picture x was like the number 3. Then our first denominator over here is 5. Our second denominator is 3. And if you look at those two numbers, you say, well, they've got nothing in common. I've really got to go. I got some work to do from there. And that's really the way you want to look at it, is that x plus 2 and x are very, very, very different. Okay? So I have 3 over x plus 2 minus 2 over x. And so they are very, very different. In fact, they don't have anything in common. So their greatest, or their least common multiple is just going to be the product of the two. So this first denominator has an x plus 2. Second denominator has an x. The only way that they're going to be the same is if I give this first fraction an x in the denominator, and if I give this second fraction an x plus 2 in the denominator. Okay? In which case, we're going to have 3 times x, which is 3x, and then I'm going to have a minus, and then 2 times everything up there. Remember, we can distribute, so that's going to be 2x plus 4, and we're going to have our common denominator of x times x plus 2. Okay? And then just try to simplify this. This is going to be 3x minus 2x minus 4 all over this common denominator, which should be 3x minus 2x is just x, so we have x minus 4 all over, and then you could either leave this factored or multiplied out. I don't think it's usually going to matter, but I'll multiply it out just so that we can get in the habit of looking for multiple things that will look differently, but they're all going to be the same. Okay? Now the second example here. What is this denominator on this x? The denominator on this x is just 1. Okay? So whenever you see something that's not written as a fraction, you can make it a fraction by giving it a denominator of 1. Okay, so this is the fraction 3 over 4x. minus x over 1. Okay? So aside from the fact that this is an extremely ugly x, we need a common denominator. So what we are missing in this fraction is a 4x, and then we should be good to go. Okay? Then they should both have a 4x in the denominator. So I'm going to have 3 minus, and then x times 4x is 4x squared. And we have a common denominator of 4x. And there's not really anything else you can do with there, besides reorder them if you really wanted. But no need. Okay? And our last example here, things getting a little complicated. We got 3 things, which means we need all 3 denominators to be the same. Okay? So let's zoom in here. We'll try to get some work. Fit some work in here. So I have a 3, a 4, and a 2. I know I can get the 4 and the 2 to be the same by getting them both to be a 4. But with the 3, they don't really have anything in common. So our least common multiple for 3, 4, and 2 is actually going to be 12. So we have 5x over 3 plus 3x over 4. I'm going to leave some space. Minus x over 2. And we're going to need to get to a common denominator of 12. Okay? And I got to that by basically multiplying 3 times 4. And that's going to be my least common multiple. So how do I get from 3 to 12? Well, I have to multiply by 4. So I'm going to multiply this first term by 4 over 4. Okay? And then how do I get from 4 to 12? Well, I have to multiply by 3. So I'm going to multiply this term by 3 over 3. And how do I get from 2 to 12? I have to multiply by 6. So I'm going to multiply this by 6 over 6. Okay? So it's very important you're multiplying by the same thing on the top and the bottom, because then you're really just multiplying by the fraction 1, which means you are not changing the value of anything. Okay, so our first term here, 4 times 5 is 20, so it's going to be 20x over 12, plus 3 times 3 is 9, so plus 9x over 12. And then lastly, minus x times 6 is 6x over 12. And so since they all have a common denominator now, we can write it as one fraction. So 20x plus 9x minus 6x all over 12. And so 20 plus 9 is 29, minus 6 is 23. So we're looking at 23x over 12 as our final answer. So again, here we are, we're trying to add these fractions. However, we don't really know what the little pieces are in the denominator. So we need to actually factor to find a common denominator. Because I don't just want to multiply the first one by x minus 2 over x minus 2, and the second one by 4x squared over 8x over 4x squared minus 8x, unless I really have to, because that's going to leave me with cubics, and that's very, very annoying. So what we're going to do first is actually factor these denominators as best we can. So if you look here, this is a quadratic. However, it's a nice easy quadratic because we can factor with a greatest common factor. So they both have a 4 and they both have an x. So I'll be able to factor this out. I'll be able to factor out a 4x. And so when I factor a 4x out of 4x squared, that leaves me with just an x. Whoops. Leaves me with just an x. And when I factor a 4x out of a minus 8x, that leaves me with a minus 2. And I could just, if you recall, I could distribute that and make sure that I end up with the same thing. X minus 2, however, is not factorable, so that's just 7 over x minus 2. And now, when I look here, I look at this first fraction and I see 2 terms down here. I see a 4x and I see an x minus 2. And when I look at my second fraction, I see a denominator of x minus 2. So they're actually a lot closer to being the same denominator than maybe we originally thought. So all I am missing is, from the second term, I am missing a 4x. So I'm going to multiply by 4x over 4x. And that will give me this new problem of 3 over 4x times x minus 2 plus, and then multiplying fractions, so 7 times 4x, 7 times 4 is 28 So 28x over 4x times x minus 2. And now that they are the same denominator, I can add them. So it's 3 plus 28x over the common denominator. And you could typically either write it in the factored form, like we already have it in, or if you redistribute it, it doesn't matter, but I'd like you to be able to recognize either. And that's how I'd be able to add those fractions. Okay? So always, when you have these algebraic denominators, factor them in the best you can, and that'll make finding a common denominator typically a lot faster and a lot easier. Okay, so we talked about multiplying at the very beginning because we needed that for addition and subtraction. Dividing is actually quite easy as well. I think I've heard a lot of students in the past remember, they always say this, they always say like keep, change, flip. And as long as you know what that means, I suppose that's a good thing to use. I'm going to ignore those 3 words for a minute, and I'll just tell them what they mean at the end. So dividing by a fraction, division is really looked at as multiplying by the reciprocal. So there's another way of looking at it. And so what I mean by that is that this is really 2/3. And what you could do is instead of dividing by 4/7, you multiply by the reciprocal of that, which is 7 over 4. Okay? And so that's where these 3 words come from, where you have 2/3, and here's 2/3. So that's the keep. The change is you're changing the operation from division to multiplication. And then the flip is talking about looking for the reciprocal. Okay? So we should end up with the answer here of, well, now that we've flipped it, we can actually simplify this. So I can simplify the 2, reduce the 2 with the 4. Trying to save ourselves a little bit of work. So 1 times 7 is 7. And then 3 times 2 is 6. So we have 7/6. Okay? Now that whole idea of division and doing the whole keep, change, flip, that seems very bizarre. So that's why I like looking at the second example, because it helps us see why that is. This is a multi-tiered fraction. They're one of the most annoying things in math to look at, which is why this symbol shows up so much, is because if you looked at everything like that, your head would explode, because that looks ridiculous. However, we do need to address it, okay? And so one way to look at this is that if I want to get rid of this denominator, if I want to get rid of this crazy fraction, I want to get rid of this 10. So let's say I want to get rid of this 10. So what can I do? I can get rid of this whole hideous denominator by multiplying by its reciprocal. So multiplying by 10 over 7x. Because then this whole piece down here will multiply and just give me 1, because these are going to reduce and these are going to reduce. Okay? And that's going to get rid of this horrible multi-tiered fraction. However, if I'm going to multiply by 10 over 7x in the denominator, I have to multiply by 10 over 7x in the numerator as well. Okay? So this whole denominator becomes the number 1. And so this whole thing simplifies to 3 over 5x times 10 over 7x. Okay? And so what we've done, if you haven't noticed yet, or if you haven't noticed already, is that we have basically done what we just did before, which is we have changed this from a division problem to multiplication, and we've gone from dividing by 7x over 10 to multiplying by 10 over 7x. So we've done that kind of keep, change, flip thing again, just kind of maybe looking at it a slightly different way. And we still get to our answer by multiplying across. So 3 times 10 is 30, 5 times 7 is 35, x times x is x squared. And we're good to go from there. Okay? Now, same thing down here, last example. If I want to divide, maybe we can skip right ahead from this. This is going to be the same. I'm going to change it to multiplication, and we're going to multiply by the reciprocal, which is 8x over 2. Okay? Which is actually can be simplified. This is 4x over 1. And we multiply 3x times 4x gives me 12x squared. And then 7 times 1 is 7. Okay, very straightforward that way. So main thing to remember with dividing is that you really want to change it to multiplying by the reciprocal. All right, so we got one really good example here for us to look at, where we have the addition and division of some fractions. So we want to, with order of operations, obviously do the division part first. So let's look at this first part here. Pull this off to the side. When I am dividing fractions, remember, I have x minus y over x. I can do the kind of keep, change, flip. I want to change that from dividing to multiplying. And I'm going to multiply by the reciprocal, which is 3 over 2. Okay, which is going to give me, now make sure we are distributing, this is going to be 3 times x is 3x minus 3y, and our denominator is 2 times x. Okay, so this is the piece that I can plug back into the beginning of our expression. So now it looks like this. It looks like y over x plus, and everything in red that we just did simplified to 3x minus 3y over 2x. Now what do we need to be able to add fractions? We're going to need a common denominator. So I have a denominator of x and a denominator of 2x. Luckily this one's not too bad, where I need to multiply this by 2 over 2 to get myself to a denominator of 2x. And so now this is the same as 2y over 2x plus 3x minus 3y over 2x. And now that we have the same denominator, we can write it as a single fraction. So we have 2y plus 3x minus 3y all over 2x. And now it's just simplifying. So the x's don't go anywhere. There's a 3x. But then I have 2y minus 3y. So 2 minus 3 is negative 1. Gives me minus y over our denominator of 2x. And there we go. We're good to go. So take it one step at a time. Multiplying or division, we're going to switch to multiplication. And always remember when you're adding or subtracting that you need to get a common denominator. Okay, we have one more little bit of a crazy example here. This is just subtraction, there's no multiplication going on, but we have kind of crazy looking denominators. So we want to, if you recall, we want to factor these as best we can. So this is 4 over 3x squared. There's not much to do with that. However, with the second fraction, what does x squared minus 2x? They have an x in common. So we're going to factor out an x. Leaves me with an x. And then when I take an x out of minus 2x, x minus 2. And our first fraction here was 4 over 3x squared. But look at this. This is 3x squared. I'm going to rewrite it as 3x times x. And the reason why I'm rewriting it like that is so that these two terms are the same. They both have an x, which means we're missing a couple of things. It means in this first term we have a 3x that we don't have here on the right. So I'm going to multiply this by 3x over 3x. And it also means that we have a x minus 2 that we don't have on the left. So I'm going to multiply this by x minus 2 over x minus 2. Okay? And now they should have the same denominators because it'll be x minus 2 times 3x times x, and we should all be good. So for the first part of our fraction, I want to distribute the 4. It's going to be 4x minus 8 over our common denominator of x minus 2 times 3x times x minus, and then we have 2 times 3x is 6x over our common denominator of x minus 2 times 3x times x. And now they have a common denominator, we can rewrite it as a single fraction. So it's 4x minus 8 minus 6x all over our common denominator of x minus 2 times 3x times x. And now we're just simplifying. My x's, I have 4x minus 6x. 4 minus 6 is minus 2. So we have negative 2x minus 8 all over x minus 2 times 3x times x. And again, you don't need to have that so factor. You could probably distribute that back out. But you want to be able to recognize it in several different forms in case it shows up in a multiple choice like that. Alright guys, so now we have some more practice for you. So please pause the video and try to go through these. And I will come back with the answers for you in a minute. So please pause them, check your notes, and try to come up with the answers on your own. Okay, so what we should be getting for number 1, we need to find a common denominator. Our common denominator ends up being 10. And we should end up with 6x minus 35 all over that common denominator of 10. Okay? And that's simplifying that into a single fraction. Number 2, we should have changed that to multiplying by x over 4. And that will leave us with 3xy. And then make sure you're distributing in that denominator of 4x minus 8. Okay? And then lastly, number 3 was very challenging. So if you had a hard time with this, if you want to try again, pause after this, I will give you a hint, which is that the way that this denominator will factor is just x times 3y plus 2. And this denominator will factor as 3 times 3y plus 2. So what you're going to need to do is they both have a 3y plus 2, which is nice, but this has a 3. This first term is going to need a 3, so we're going to multiply by 3 over 3. And this term has an x, this term is going to need an x, so we're going to multiply by x over x. Okay? So try that, get that common denominator, pause again if you didn't get it. And what you should ultimately end up with is the fraction 3y plus x squared, the order of those two doesn't matter, over your common denominator, which is 3x times 3y plus 2. Okay? So if you had any trouble with those, go back and look for similar examples in the word problems. If not, good luck on the practice with the key that's listed there, and good luck on the post test.